In this exercise, you will learn to create layers, design the attribute table, and digitize data. During the activation of the software, we will select Map. Here you will have to define the name location where the new ArcGIS Pro project will be stored. Vector data represent geographical entities as points, polylines, or polygons. Importing them in the GIS is usually done through digitization. In all vector data, the information is divided into two parts, the geographical and descriptive. As we mentioned in a previous section, the geographical information concerns what is shown on the map, whereas the descriptive information is the database shown in the attribute table. The process begins with creating an information layer containing the vector data. Through the Add Folder tool, set the folder where all activities will take place, so that there is a direct connection with it. In the catalog, right-click the folder where you want the information layer to be saved, and use the New command so that the new information layer is created. By selecting Save File, the Create Feature Class dialog box will appear. In the Parameters tab, in the Feature Class Name field, define the information layer's name. For this exercise, the name is Boreholes. From the Geometry Type field, set the type of entities the information layer will contain. In this exercise, the file contains boreholes. Therefore, the geometry type will be point. Then, in the Field Coordinate System, select Greek Grid, which you will find by following the path Projected Coordinate System, National Grids, Europe, Greek Grid. The Feature Class Location field is already completed and concerns the location where the new information layer will be stored. You don't need to fill this one because you defined it indirectly by creating the information layer through the catalog. To create a point layer, select Run. Observe that the information layer appears in the table of contents. Also, observe the map window. Can you see any new layer on the map? No, because we haven't yet added any geographical entity. This will be done through the digitization process. As we said, a vector layer includes both geographical and descriptive information. Therefore, you have to design the database, and this is the time you learn how to do it. Open the attribute table through the catalog. Right-click the corresponding information layer and select Data Design, and then Fields. The fields Safe ID and Save are created automatically by the software and we cannot modify them. The FID field shows the serial number of its entity we create. The shape field concerns the geometry of the entities of the information layer, which is a point in this case. The ID field can be used or even modified according to the descriptive data. To add a field, for example the name of every geographical entity, you need to click here to add a new field. In the data type, select Text. You can also modify the length of the text. We will also add the altitude. Save the modifications you've made by clicking Save. The most common ways of inserting vector data is digitization. For all types of vector data, digitization is done through the Editor toolbox. For your exercise, you will import the map testmap2ggtif in your project by creating parents. Moreover, you will georeference this map using the Greek grid. And then you will save it in TIFF form. So now we will create features. In the Edit menu and the Features tool group, select the Create tool. The Create Features window will be activated, where you will determine the parameters of the digitization. For the Templates tab, select the boreholes layer to be digitized. Now you can create a point through the Point tool. It would be good to zoom into the area you're about to digitize. Select the Point tool to start digitizing and inserting a point by left-clicking the corresponding location. In the Create Features window, you can see a message letting you know that the point was successfully being created. By activating the attribute table from the table of contents, you can insert information about its geographical entity. For this exercise, you will also learn to digitize polylines and polygons. From the catalog, right-click the folder and select New Command and Save File. In the Create Feature Class dialog box, for the Parameters tab, define the name of the information layer in the Feature Class name field. In this case, the name will be Contours. In the Geometry Type field, since we want to digitize contours, we will select Polyline. Set the coordinate system, which will be Greek grid. You may also add Greek grid to your favorites to find it easier. Complete the process of creating the information layer by selecting Run. Right-click Contour Shape File. Press Data Design and Fields. In the Attribute table, click the Click Here to add a new field command. Here we will add the field Altitude. Layer creation is completed after designing the database and saving it. Once you have created the information layer and designed the attribute table, it's time to insert the geographical information. Inserting will be done through digitization, and therefore we will use the Create tool in the Edit menu and the Feature tool group. In the Create Features pop-up window, through the Templates tab, select the Contours layer which you will digitize. Here, you need to zoom into the area you're digitizing, and through the Line tool, you can digitize the contour lines. Every line is inserted by left-clicking. In fact, by left-clicking, you create a node. If you create a second node in another position on the map, you will notice that between the two nodes, a straight line has been created. Repeat this procedure until you have drawn the entire line you wish to digitize. Repeat this procedure until you have drawn the entire line you wish to digitize. When you finish designing, you can double-click the last node, thus ending the process of digitization. In the Create Features window, you can see a message that lets you know that the polyline was inserted successfully. Afterwards, select the Save command so that the geographical entities you inserted are saved. To insert the descriptive information for every geographical entity, you need to activate the attribute table. You may also select the attribute table and modify. This map shows the geological layers. The yellow area is alluvial deposits, the blue is marbles, and the green is schist. In the catalog, right-click the folder and select the New command and Zip File option. The name will be Geology, since our information layer contains geological formations. The geometry type will be polygon, and the coordinate system will be Greek grid. Right-click, select Data Design and Fields. You can add a new field in the attribute table. In this case, you will add the name field. In this area, you will insert the type of geological formation of every polygonal geographical entity. Afterwards, you need to define the type of information the field will accept. Through the Data Type field, select from the combo box the appropriate type, which in this case will be text. The creation of the layer is completed once you save the database by selecting the Save tool of the Changes toolbar. Once you have created the information layer and you have designed the attribute table, it's time to insert the geographical information, and therefore you will use the Create tool from the Edit menu and the Features toolbar. Selecting the geology, you can create a polygon by inserting nodes using the polygon tool. In this point, you need to zoom into the area you're digitizing and use the polygon tool to digitize the geology. Every polygon starts being inserted by left-clicking. In the Create Features window, a message appears that lets you know that the polygon has been created successfully. To insert the descriptive information for every geographical entity created, you need to activate the attribute table. Now we will select only a small part of the marbles. In this example, you will notice that some of the geology polygons are fully contained within others. Therefore, if you select the inner polygon through the Select tool, you will see that the software allows you to choose between the inner and the outer polygon. In other words, even though the inner polygon is a different geological formation, the software thinks that the inner polygon is part of the outer. We must separate the inner and outer polygons. To do so, in the Edit menu and the Features tool group, activate the Modify tool. In the Modify Features pop-up dialog box, in the All Tools tab, you will find the Clip tool. By selecting Clip, the anonymous Clip dialog box is activated, where you will define the part of the polygon that will be separated. You may remove the common area through the Discard option, preserve only the common area through the Preserve option, or separate them and keep both areas through the Split. You may also define the buffered distance, that is the zone around which the clip will be done. For this exercise, the marbles polygon contains a small appearance of schists in the inner polygon. In the input, select the inner polygon, the schists. In the Target features, select the target you want to click, which is the marbles. As the polygon is selected through the Clip tool, you remove the selected region.